Let the madness begin. My friends, my colleagues, my peers, I want to say welcome. If it's your first time watching me, I want to say welcome. If you're following along with the saga, like most do, I want to say welcome back. That makes you a repeat offender. Today I had a sad thing happen. This is my soldering iron holder. Now, I know that the instant that I put this out there, there's going to be 20 people that are going to actually be able to find this holder on the internet. And if you do, please just shoot me a quick text and say, hey man, this is where you can go buy this holder. This is a 3-piece holder. It's weighted. There's a weight that's actually in the base of this thing. As you can see, it's much thicker than the actual sponge holder. The little Bakelite material, you gotta remember this holder is like 10 years old. But BBI, it doesn't look like it's 10 years old. It's because I completely rebuilt it. The little Bakelite holder, there's an inner and an outer sleeve that's in this. I'm not gonna get it to come apart. I made it too tight a tolerance. There is an inner piece of serrated punctured metal like this on the inside. You can see it sitting here in shadow. See it in there? This is what holds my soldering iron. This is like my right hand of God, okay? I do 99.9% of my work with one of these guys. The Weller stainless, or not stainless, but stained glass window iron. This is my holder I've used for 10 years. I didn't want to go to any of the other holders that they have out there. I love this holder. But the Bakelite material, finally, which I've had held together with aluminized tape and wire and glued several times, is just finally the other day just completely disintegrated. I went and I tossed the iron because I'm really famous for doing that. I literally, which isn't the best iron discipline, I understand that, but I do it anyhow because I don't care about the iron. It's just a tool. I keep 2 or 3 of these around here at all times. If this one's quits, I gotta have the exact same tool to put back in there. Hell, I believe in the thing so much I put it on my arm. I like literally put it on my arm. Me and this iron are friends. But I took the time to straighten this out. I took the time to bake all the flux off of everything and chemically wash it. And then I took from an old Harbor Freight jack handle that I had laying over here, I cut a collet off, and then I sat here and chucked this up and then spun it with a file and just kind of hand milled this back to where it was the perfect OD for the inside of this with the right leading edge. Then I did the same thing in reverse, but then I did a tapered input. Now, I don't have a lathe, which I should probably have at this point. Even have a mini lathe at this point. Where would I put it? I'd be sacrificing room to store other people's equipment that's here for repair. So I just roughed it out old school, and I was able to build myself a new holder. This makes me very happy. But believe me when I tell you, everything over here stopped until this was fixed. And this is something I knew I've needed to do for a long time. So just want to share that with you. It came out okay. We got a coating of black Cerakote on this. At least that's what they claimed it was when I bought it off of Amazon. So who knows what it really is. This is the stock sponge, which I have never used. It sits in there and it just has solder drip on it. If you guys can find this, I've spent hours scouring the internet. I just don't have any more time to put at it. I'd love to buy another one of these to have as a backup sitting on the shelf. Or if you guys got one of these, it's a 3-piece unit. So it breaks down to be basically these 3 pieces. I don't have a manufacturer's name, and I bought this at a local electronic shop, supply warehouse that has hence gone out of business. So if you guys out there in the Interbublin know where I can buy this stand, again, I would really appreciate you getting a hold of me and let me know. This is my soldering iron station. I got my Weller multi-tip here. It's about 600 and get up 600-700 degrees out of this little iron. This is my Etzen which was my very first soldering iron that my dad bought me when I was 16 years old. And up until then I was using his Weller, which he took back, and then I got this thing. This is not the original Edson I've had. I've worn it out. This will be Edson number 4 that I've had. The only thing that has stayed the same is this cord attachment and this handle. I've had the potentiometer quit. I've had the heat control unit quit. Oh, and the tray. So I've got 3 or 4 of these trays. But this is just a regular sponge that I fill with water. And as you can see, I clean this area out here all the time. But this area here, because I'm busy doing whatever as I'm working, I clean this about 3-4 times a year. I could not believe the amount of solder that was inside of this stand. I mean, I couldn't believe it. The whole ass end of this thing, was full of lead. And all of this, it falls out the back. That's the reason I got it sitting on a towel. Otherwise, the back end of the workbench would look like ass. So all I got to do to clean that is literally pick everything up that's on this towel and go shake it over a trash can, and I'm back in business. And I do that a little bit too. This is a Hacko. My business partner sent me this. He said I needed to use this instead of water. They claim that this is less aggressive. What's in here is this is a brass shavings. And they claim that microbursting that takes place with the soldering iron, when you go to clean it on the sponge, like this, what you're doing is creating a little bit of steam. And that microburst of energy, with the steam pocket exploding, is supposedly harder on the tip. I argue the other direction. Taking a hard metal surface, or a harder metal surface, harder than steam. Brass is definitely harder than steam, in my mind, the way I see it. The whole idea behind this is to put this in here and drag it, like so. Well, even though brass is very soft, to me that's like taking a file to this tip, which is never good. I buy stock in these tips. Once I start to see any kind of little pivot or a breakdown in the coating that's on the tip of this thing, which there is a coating, believe it or not. Here, let me give you an example. This is an old tip that once the tip starts to have a breakdown, it will quickly disintegrate. It'll go from this long tip here there's the 2 units next to each other. It'll quickly break down and disintegrate away. There is a coating that's on here, and I do everything I can to keep from having this coating get violated. Once that coating gets chewed up, the flux, the constant heat, we start to have metal migration, and it quickly turns into, well, let me pop this tip out of here. This will turn into that in just days. So to drag this over any metal surface to me is no, bad. So I stick with a sponge. That's just me personally. But I mean, like, this is the soldering iron stand that we most commonly find everywhere. I don't like it. I don't like the sound of it. I just don't like it. I don't like how it supports the iron. I don't like it. But I'm really happy to have that running again. But I thought I'd come to you as the community, my radio buddies, my electronic community, and say, gentlemen, help me out. Now, that being said, it wouldn't surprise me none whatsoever on any level that the company that makes this has gone out of business. And it's almost impossible to find anything in today's day and age that isn't made in China Schmoo. I don't even know why I keep this tip. I don't even have this cordless iron anymore. If anybody out there needs this little ISO tip for their cordless soldering iron and you can't find one, give me a shout. I will gladly just give it to you. I can't throw it away because I paid money for it, and I can't do it. Well, the reason that we're all here today and you're watching along is because we're going to work on these 3 amplifiers. This is a Pride, this is a Pride, this is a Palomar, and this is a Texas Star 250 Killer B that has been heavily modified. on the inside. Both of these, we're literally going to hook them up. And if they don't work, we're going to throw them away. I might pull the transistor out of them, but we're probably going to end up pitching them, because they're in such rough shape that they're not worth putting a ton of time or energy into. And when these were being made, these were the epitome of the truck stop amplifier. This is the truck stop amplifier, your classical Palomar. Look, these are good little boxes, and the guys that made these in the 70s, 80s, and into the 90s are dying with laughter on the inside, seeing that people are still putting in energy trying to have these repaired. The whole point behind these 3 amplifiers was that when they break, they were so cheap, you throw them away. Now, what has come in and filled that void in the market? No, seriously, I'm asking you guys to say out loud to yourselves, what company has come along in the last 10 years to fill this void? Because Palomar slowed down production. Pride's no longer in existence. Now, there is the knockoff Pride, per se. I will say this. Listen, I've made it my business to never say anything negative about anybody. It's not my job. My job is to fix the amplifiers and approach it from a neutral point of view. It's my job. As in all things in this world, any hobby you get into, I don't care if it's racquetball, for my buddy that's really into racquetball, and he constantly, every time I deal with him, he talks about the drama in radio, and he compares it to his racquetball life. Or if you're in race cars, or if you're into competition shooting, or if you're into... There's shit talk that goes on between everybody. Me personally, I don't like to get involved in that. So I never say anything negative about anyone. I really try not to. Unless you're building a product that is false. False. Okay? There is a company or a gentleman that says that he has some kind of affiliation with Pride at some point or another. We went out and found the people that used to be at Pride. First off, they're all in their 70s, 80s, and 90s, and they have never heard of this guy. Okay? So there is such a thing as called name trading. I'm going to take the name of a very successful, well-known company that might not be in business, and I'm going to use their name to sell my product. Unless it looks like this on the inside and it is old school, that means it has been made by a modern company today. And the guys that all worked at Pride have no idea who he is. Just going to say that. In the same breath, the age differentiation really makes it clear as well. But be very leery about what you buy. These are both Pride 100s. This is a staple. This was a lot of the people that built this were disabled or handicapped in some way, and they were just working. You know, Pride said, "Hey man, you can work. Come to work for us." And so they built these amplifiers. They built a lot of them, and then they closed the doors and ran away, which you should do. You know, it is what it is. There's a difference between the two Prides. This one has a input attenuator, which to me looks like to be stock, taking into account the way the wires are set up. We're going to cover each one of these thoroughly. Believe me, if they don't work, I'm literally going to take them and throw them in the trash, because it's not worth us putting the amount of time into them because of their construction style. And there's huge differences between the two boards, even though they look remarkably the same. So let's start off with the two Prides. We'll come back to the original throwaway amplifier and get it probably going, most likely, because people love their Palomars. They do. And then at the end of the coup de grace, we're going to do this Texas Star Killer B250, which has got an RF radio meter. This is the end of the Mr. V project. It is. These 4 amplifiers represent the last of this project. There is one amplifier that's over here that is broken that I know for a fact, and it is absolutely not worth repairing or putting a single minute into. So I started this whole segment with asking you guys to ask yourself a simple question. What is the amplifier that is currently being produced that falls within this category of equipment? It is so cheaply manufactured that after you pay somebody in America to take it apart, figure out what's wrong with it, find the parts, put the parts back into the thing, and then send it back out the door, it's not worth doing. That is RM Italy. RM Italy makes some very nice stuff, as in they make some good 2-meter equipment. They've got a lot of different amplifiers on the market. You'll find RM Italy, they'll make one product, they'll make a run of it, they'll use one style of transistor in it that is, well, labeled just for them, and there's no cross components for it anywhere because the components are bulk made in China. So after we go through the whole process of getting the amplifier here, going through it, figuring out what's wrong with it, identifying the part that's broken, figuring out the part number, getting a cross reference for it, finding that part and getting it delivered here, not worth fixing. I had I had an RM Italy that got abandoned here. I had a guy call me up. It was a 500 watt RM Italy. Sent me the RM Italy, waited for the entire time for it to go through the process of getting repaired. I took a look at it. I said, okay, man, it's going to be about $300 to fix it. And what had happened is he put way too much drive in it, and he burned all the input traces off the damn amp. I mean, like all the relay, the keying circuit, everything was destroyed. And he'd popped 2 transistors. I said, well, this is going to be after my time, which is going to be a couple hours, the cost of the transistors, which is about $100, and of the other miscellaneous parts, relay, and a couple of other upgrades to it, it's going to be about $300. He goes, do it. I said, okay. So I go through the whole rigmarole, and then I call him up the next day, and he says, well, man, I got on the internet last night, and I was able to find a brand new one for $250. And I'm like, so I'd just taken a whole day and like wiped my butt with it and threw it on the table. And he goes, I'm going to go buy this other one. You can just go ahead and keep. I don't want any of this stuff. Let me say that too. We're not interested in keeping any of this stuff. He goes, you just go ahead and keep that. I'm going to go ahead and buy this brand new one off the internet. Bye, click. There's a silver lining to the story. I met a guy that is a local here, a very young man. And he was told without a shadow of a doubt that he would never, ever, never, ever be able to have any kind of amplifier or power ever for any of his radio equipment ever, and that he should just, quote, get off a radio. I heard this a couple months ago, and I went. I got a hold of him through some back channels, and I said, young man, come see me. He rode over here on his bicycle. I met him out. I said, here you go. Just gave it to him, said, here you go. He was so tickled. It was like, the expression on his face was priceless. So, at the end of the day, is there value in these? If they work, we'll do power wire upgrades to them. We'll make sure that the input networks are all set up, the input and the output tunes are all set up, that they're spectrally somewhat clean for what they are, and we're going to get rid of them for dirt cheap. These are probably $60 to $80 a piece at the most on a good day in working condition. So let me reset the workbench and let's get on with it. All right, now that I got new batteries in the microphone, let's get this squared up. I love this tripod that my business bro and I bought together in Texas one time. It's just, are we, okay, leave it alone. Let's get a graduated pointing device. Here we'll use these brand new Klein insulated screwdrivers I bought myself. These are guaranteed to not kill you up to like 1,000 volts. Anywho, it's orange, looks pretty. Big camera, big tripod, kind of a bee to work around, but in the same breath, we get to enjoy the really high 4K plus resolution video. Then I have to dumb it down to upload it to YouTube. Okay, we're going to talk about, these are exactly the same amplifier on the front, by the way. This is a Pride 100A, and the A is rubbed off. This is a Pride 100A. The A is not rubbed off. The switch pattern layout, the LED layout is exactly the same. This one physically on the outside is in a little bit better shape. This is a later iteration, okay? This is a older iteration. This is a single-sided layered board. This is also a single-sided layer board, okay? Which means all the components are soldered to the top side of the board. All the components here are soldered to the top side of the board with the adaptation of a single-sided pass-through board. There is a third version of this box, roughly. I think there's roughly 4 different versions of this. They're all basically the same. This particular bit of architecture in here, around the transistors, there's very little deviation from A to B. It's just like a Texas Star. The only thing that they change is either the cabinet or, in Pride's particular situation, the way the relays are attached. Okay? For a while, I swear to God, Palomar was using the same circuit board in some of their equipment. And I've actually seen a lot of Palomar amplifiers, old Palomar, not like that yellow thing that we're getting ready to go through, where they had a separate board. Palomar and the Pride amplifier, they had a separate board that enclosed all of this electronics in here. Now, we see that this resistor here, which goes to ground, is blown. And that's because the way this thing is mounted, the relay's flexing. Well, the components are taking that flex vibration. You got to think, as this is running down the road, it shit's vibrating. Well, the next generation, they came up with this particular design of board, or close to it. Just so you know, let's see. Let's identify our components here. Yep, this is our preamp transistor. This is our keying transistor, conveniently in the top corner. Same thing here, keying transistor. Once again, our preamp transistor. So preamp relay, our transmit relay, preamp relay, transmit relay. It's the same components, just slightly different layout. When they went to the flat pack, they took this board and they orientated it this way, and they made an iteration change to it where they went to a flat pack relay. Those are the worst to work on. Because to do it properly, the solder traces, like on this amplifier here, our solder traces are on the back side of the board. Well, now suspended on the board flat. So they took this board and they flipped it flat. So all our traces are on the bottom, but all our components are on the top side. There's no way to really desolder and resolder the component short of cutting the legs off and then soldering to the legs of the component on the top side without completely disassembling the ass into that amplifier, which in those particular iterations means removing all of these leads coming in and off the board, removing our leads going out to our antenna attachments, and then removing the coax connectors and pulling the power wire out. Then you can pull the board out and replace the keying transistor, because that's normally what goes bad. So usually every one of them that I see that comes in here, the keying transistor has been cut out with a pair of wire dikes very close to the very top edge of the transistor, and it's been replaced with another transistor soldered to the legs. It works. Once again, it's about a time versus the worth of the amplifier. To disconnect all these wires, pull all that shit apart, right? And then reassemble it just to test it to see if you've got the actual orientation of the transistor right, because some of these older components you can't find crosses for them. Most you can, and I understand how to use the internet too. That's why I keep all the old transistor books, because some of that stuff hasn't been scanned yet. I'm sure it will be. And who knows what Google's going to actually let us find anymore. I just wish search engines and big platforms like, you know, Twitter and Facebook would stay neutral. They would be so much more successful if they would just stay neutral. Just neutral. No opinion, just neutral. Like Google. Not neutral anymore, unfortunately, but it is what it is. It is what it is. I don't want to piss off the great overlord overminds that run the entire universe, Google, so they should just stay neutral. If I had an opinion, they should stay neutral. Just me. So you don't really know when you type into the search engine what you're going to actually get for results versus pushed results versus clickbait. So, I mean, some of this stuff, some of these transistors that were made for a month, Pride bought them, figured out how they worked, base emitter collectors on them, and did a run with them, and there's no data sheet for them. Or they'll come up and it'll have a replacement. But all that in all, if any of these components burn up on the later iterations of this, you have to like strip the whole amplifier into half. We're talking about 25 amps when it comes to any of these little 2-pills. About 25, at the most 30 amps if it's a really horribly inefficient component or a horribly inefficient circuit. Prides take the cake. Hands down. Prides take the cake on the worst voltage control setup that there could possibly ever be, and the best in the same breath. Let's set this guy aside. Let's turn this sideways. And let's zoom in here a little bit. Let's talk about this. Now, if you are used to looking at any other amplifier other than this, they did this, Pride did this, and Palomar did this. I swear that the two were like friends at one point or another. You got our 12-volt lead that comes in. We have a giant 25 or 30 amp protection diode here. And then we've got our output for our relay, which runs down, comes along this trace and goes over to our relay. And then we have our output, comes down and goes over here. We've got our isolation, a couple isolation capacitors, which are going to throw the resonance of this lead and the switch and all this other stuff completely out of whack. So RF that's on this transformer doesn't want to run up this wire, run past these ferrite beads, which is not resonant, then run through this little tiny wire here, up through the switch, up through the relay contacts, and then out the amplifier. So that's how we have our setup going on here. In my opinion, this is the largest waste of current inside this box. Now, that being said, it's beautiful and elegant from another point of view. There's always another point of view, and we have to look at it from both points of view. For us to get efficiency, like what we're going to do is we're going to take this wire and we're going to literally put a choke on it. So there's an uninterrupted hunk of metal mass with some ferrite on it, and we're going to bring it right to the output transformer. There is a measurable voltage difference between this wire. Let's say we hook this up to a voltage source and we measure it. You're going to see like half a volt worth of drop from here through the switch, through this little tiny lead over to this transformer, which is resistance. Now, I remember looking at this when I was about 15 years old. I was a little kid. I had my friend, his name was Kerry went by Bouncer on the radio here. And I said, man, this makes no sense to me. I had to look at this whole circuit and I'm like, this is dumb. And Kerry went, no, it's brilliant. I said, why is it brilliant? He goes, well, what do you see that's dumb? He was talking the circuit through to me logically. Okay, this is what we call learning. I went, well, this is dumb. The switch is going to resist current, and this little tiny piece of wire, there's no way that can carry enough current. And this little tiny piece of wire going up here, there's no way that can carry enough current. And he went, young man, wait. As you go down in size, your amperage load can go up as you go smaller and smaller, and they're capitalizing on the fact that there's only 30 amps worth of consumption here, and this little tiny piece of wire is basically like a linkable fuse in a sense. The way he put it was elegant. He goes, you can take a small piece of wire and pass a lot of amperage through it over a very short distance. Think about it. And I went, oh. We see this applied in fuses, the same technology. And there's actually more than enough metal mass here to carry the little amount of current that this little 2-pill transistor is going to use. Me personally, I like to bring the 12 volt in, unisolated from anything, not let it be molested, and attach it here. And then all you've got to do to pick up that extra, I mean, we're talking about 10 watts worth of picking up. We're going to pick up like 10 watts by doing this. Take the wire, go to here with it, then take another wire and bring it back over to here for on off. The elegant bit of this only comes into play into one application. Is if you have all the switches off on this thing, and for some stupid reason you hook it up backwards, no components will be harmed until you flip the switch on. You're going to let the smoke out elsewhere. It's going to come out here. Your ground wires are going to just disintegrate. Because think about it, if you hook it up backwards, you're now grounding the case, which is going to be grounded through your coax and grounded 9 other different ways. And I guarantee you it's going to be more substantial than this little piss-ass wire that comes on the amplifier. So, but your transistors at the cruxus of the thing aren't going to take the brunt. Where, I don't know about you, most people, how they do things is they'll hook up your power wires first, then hook up the coax connectors. Well, if you got your power wires backwards for any reason on any other style of amplifier other than this, and you don't catch it right away, or that switch is on, your transistors take 100%. I don't care about this diode. This diode's here in a very humble, vain attempt to try and stop the destructive current from flowing back and wiping out your transistors. This diode might as well not even be in there. From what I've seen in my tenure, I've seen several of these hooked up backwards, and this diode's always blown, but so are the transistors. The diode is designed to be hooked up back. If it gets hooked up backwards, this diode will break down and short out, telling you that you have a problem and popping the fuse down line and supposedly protecting your transistors. Supposedly. In theory. And it also acts as another form of AC clamp on the output circuit, but I'd like to believe that this is some kind of protection diode. Myself, it allows me to sleep better at night and be cuddled up with, you know, oh, it's gonna save the world. I was just sitting there talking with my business partner on the phone. We were BSing, and I'm looking down the opposite side of the shop, and I seen these 3 switches hanging off the shelf, and I went, Gen 1, Gen 2, and here's a perfect example of Gen 3. You see any characteristics that are shared between the two? Working on these sucks. You pull your power wires, you disconnect your coaxes in the back, you can flip the board up, and then you can go to work on them. These Potter Bumfield relays are a little bit hard to find, but they're still totally available. These relays are also totally still available out there. But you also have to understand that this is the way they were building back then. This was the common blueprint. This is what people knew how to do. And this, literally, this board is a direct, comes right out of the Motorola Handbook volume number 2. Okay? So therefore, a lot of these companies are going to share a lot of the same principles. But I mean, you can see that the disc capacitors are the same. They're in the same place. Protection diode, protection diode, protection diode. The only difference is the switches are on this side of the cabinet instead of over here. Literally how the power wires and the power distribution traces on the inside are all laid out the same. The way the RF comes in and goes out, same transformer, slightly different transformer, same transformer, length and material make, by the way, same transformer. Different way of getting there. This is 2 continuous pieces, this is 4 pieces, this is 4 pieces. Same length, same capacitance loading, same tuners on the input. It's a copy and paste situation. Copy and paste. I want to say thanks, Rudy, by the way. Rudy sent this in. This will probably go at our next break. He sent this in as just a break donation. And I'll button this up here in a minute, but let's get back to the task at hand. He sent this in as a break donation, and I just happened to have it sitting here, and I thought I'd give you guys a visual example to tie this whole thing together. Cookie cutter. Cookie cutter. So let's go ahead and let's hook up our ground lead. And all we're doing is we're testing to see if the thing's working or not. That's our main goal. Okay, so we're just going to use little alligator clips. Remember, we've only got a couple amps. We're obviously working at 12 volts. Let's go over here real quick. Let's establish our units of measure. That's a 100 watt slug, 100 watt slug in average, and a 5 watt slug in reverse. So, and there's guys out there that love these little amps. I mean, they love these amps, and I don't blame them. You love what you're accustomed to. Like me in car audio, I love vintage audio. And what I mean by vintage is 2000s, 99, 90s. Love it. I got to be really careful. All this wire is cracked in many places, and we're not shorting out at the moment, so we're grateful for that. I don't want to move that wire around too much is what I'm saying. It might cause an electrical short. So let's turn on our 2950. Power's on. We have no preamp. Just probably a blown transistor. We'll come back to that. It's no big deal. AM and sideband. Preamp off. AM, power, amp, off, on. Something is amiss here. Preamp relay is engaging when I turn the power on, even though the preamp is off. We'll come back to that. First off, let's see if we can talk through it. Hello, audio. Not looking so hot. The needles are moving. Hello, audio 1 2 1 2. Let's go look at our pass-through, or otherwise our ability to talk through the amplifier. Hello, audio. That's with the amplifier out of line. Not looking too encouraging at the moment. So let's see what happens if it comes out of preamp mode. Hello, audio. So making 40 watts of power. Hello, 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 audio. But the relay's fully staying engaged all the time. Hello, audio. So the amp is never actually shutting down. So that tells me that we've got a problem here. And I can't believe we're actually able to talk through it. Relay engaged. You can see the relay engaging. Remember, transmit relay, preamp relay. So, let's get out our handy dandy FLIR. The 40 watt output. Most powerful tool in the world, though. Working on any electronics, I swear. Okay. Hello, 1 2 1 2. Hello, 1 2 1 2. It tells me that we have 2 good transistors in here, but the circuitry around this thing's a mess. Well, we're getting power out of it. Probably output tune's way off. Input tune we know is way off. That's this puts this on the fence. The transistors are good, but do we want to spend the time trying to undo this mess for like a $40 or $50 amplifier? We'll put that one aside. Let's hook this one up. Now this is asbestos coated wire that's on here, believe it or not, which isn't that big of a deal to me, knowing how asbestos works and its insulation properties, which there's nothing like it on Earth. It isn't manufactured chemical. This is a naturally occurring substance. I do not want to take and do anything with this wire. Like, I will not cut it. I will not put it in a situation where it can be turned into a a particle that we could breathe or inhale. Like I'll cut the wire back here and I'll probably cut it through the butt splice. And then I'm going to take and we'll throw this away. Okay. We don't want to solder to this. I don't want to do anything with this, but this is old school asbestos coated high temp wire. And even at that, me touching it with my hands, because I might have a rub issue. I'll probably go wash my hands here in a minute after we're done shooting this segment. All right. LEDs are lighting up. Preamp is also popped. Now we haven't changed anything with the radio, and look at what the watt meters are doing. Hello, how to go? Hello, 1 2 1 2 1 2. Hello, 1 2. Okay. Here's our pass-through tune. Hello, 1 2 1 2 1 2. That's acceptable. Now let's come back down here and let's look at our watts passing through the amplifier. Hello, 1 2 1 2 1 2. About 20 watts. So our dead key is about 2 watts. About 3. Let's turn this down to a watt. Sorry. Let me bring you into a full circle. I took and flipped the 5-watt slug around, and we were keyed right about here. So 3 watts in was getting us 80 out. Let's go ahead and we'll bring this on down to about a watt. Turn the volume down on the radio so we're not listening to static. We'll turn our 5-watt slug back around, so now we're reading in reverse again. Hello, audio. Hello, audio. 100 watts. That's what this makes. On 12 volts. Running through alligator clips. Let's bring the power supply on. Hello. Now we're making over 100 watts. We'll go to 2x. Hello, audio. Now we're making 160 watts. 1,000. The 60 is 12. Or pardon me, yeah, it's 12. So it'll be 120. Next hash mark 140. The 80 is 160. Hello, audio. We're making almost 200 watts. And that's without touching our tuning potentiometers. Now, that being said, also, let's go up and look and see what our input tune is. We're just talking about our pass-through, our ability to talk through the amplifier. Hello, audio. That's our input tune, which is deplorable. Either way, I'm going to be into each one of these amplifiers a couple hours worth of labor. I'm going to be into both of these a couple hours worth of labor. Now I want to come back to this one here. I just wanted to establish both of these are working, ish. But I want to come back over to this one and I want to retest it. We know that the transistors are good. This particular pride has got CTC G100C transistors in it. Real common number, right? This has got Q100S's in it, made as a part number of SSS, whatever. The reason I want to revisit this amplifier is because when we were on it before, I totally forgot to check out this, our input attenuator, which is nothing but a set stack of resistors on the input network. So it's set at -50. It's got -50, -50, and then it looks like 101 scribbled in the ass end of this thing in Sharpie. So let's take this back down to 1x. Turn the amplifier on. Hello, audio. Hello, audio. Let's go back to where we had it set, which was all the way to the right. Hello, audio 1, 2. That would be low. Here's medium. Hello, audio. Hello, audio. There's high. Take our meter up to read 2 ags. Hello, audio. Same amount of power output. So we know for a fact that these are all 50 volt transistors that are in both of these boxes, right? The question is, which one do I want to spend my time getting running? Data 1 or data 1? Don't know. Well, that's a fun way to spend a couple hours. I spent way too much time on this to get this right-ish. So the key-in circuit, the transistor that was in here, which is one of these two, the same transistor. I'll put them over here so you guys can see them. One of those two was completely blown because it was in backwards. And the exact same situation was with the preamp. So I figured out which way was the base emitter collector, worked out the fact that they are actually PMPs, and replaced them. These are 2N2907s or 2905As, which is a great cross for the 2N2907 that I've got. The preamp circuit will not stay latched, but I also noticed that the protection diode that's over here on the board was, once again, had been replaced and put in upside down. And I think there's something wrong with the coil inside the relay, and it will not stay latched. It sits there and hums no matter what I do. And also when the preamp circuit is in line, there you can't talk through the box. You forget it. You're not talking through it. So instead of spending any more time on this trying to chase down which one of these caps is bad, I have to draw the line and I've got to move on. So we're gonna just let this one go, power on, sideband delay works, just no preamp. No shame to the world there, ain't nobody gonna miss that. So let's go ahead and let's run around the gambit real quick. Now I have repainted the tin. I've been twiddly farting around with this for so long, the tin is now dry. It was pretty rusted. It looked like smashed asshole, to put it mildly. I went ahead and rough sanded that back and then hit it with a layer of flat. So the tin doesn't look half bad. I mean, it's not by any means pristine, but we got most of the rust covered up. That's really all we need. We're just looking to make these things work well enough that somebody might actually want to spend a little bit of money on them to buy them. We're not making them Cadillacs, because believe me when I tell you this, even if I ask $100 for this, the guy that actually put the money into this because of this name, and he went and bought them off eBay, he's losing money at that. Plus I've got to think of my time in it too, right? I can put a BBI sticker on that and it, so what? The amp is still a Pride 100 with stock transistors in it and slightly upgraded power wire. So let's go over here. Let's turn up our volts. We're on 1X at the moment. Here's the radio. Hello, 1 2 1 2. Amplifier. Hello, 1 2 1 2 1 2. Hello. That's an average bird of over 100 watts. Let's see if we can suppress that harmonic. See that little secondary harmonic? That would be adjusted here. Good enough. You can't tell I'm kind of over this. Let's go up to 2X. Hello. Off the chart. Down to 3. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2. That's 300 peak. Hello, and well over 100 bird. Hello. Now this is the unit that's got the attenuator built into the ass end of it. So let's put it on what would be considered to be medium. Hello, 1, 2. Let's go ahead and go to low. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Let's go look at our input tune. I gotta get some more color-coded wire inductors, or I think I could have fixed this. Hello, 1, 1, 1, 1, 1, 1, 1, 1. We're looking at this in reverse. 1, 1, 1, 1, 1, 1, 1. Hello, 1, 1, 1, 1, 1, 1, 1, 1, 1. That's in medium. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. That's on high. So for a little 30 watt drive amp, we're getting around 300 watts out of it. Now that it's all been tightened up and we got stuff that's actually put in appropriately front to back, we're going to call this Palomar 100A 1. So now, physically this one's in a little bit better condition on the outside. This one's also got a bunch of burned up parts on the inside of it. It is technically working. So I'm going to ask, let's say 150 bucks for this. It's a 300 watt amplifier. 150 bucks. Can't go wrong there. Somebody out there's got to have this. We'll get the tin slapped on it and we'll have it on there by the end of this video wrap. So let's go ahead, let's switch gears now. And let's go over and let's flip-flop onto this old girl. Please note over here, we did do the power wire upgrade. We brought the wire to the transformer, and then we took this bead and brought it up to the switch. So the only thing the on-off switch does now is turn the keying circuit on and off. And we're going to go ahead and we're going to emulate that over here on the Palomar 100A2. Okay. Pride 100A2. Now, same thing as before. The tin was all rusted up. Looked like ass. We went ahead and sanded it back a little bit and painted it. Now, remember, we got completely different transistors inside this amplifier. These are the CTC 100Cs, whatever that means. I'm not going to go bother pulling a data sheet. Now, our measurement tools have stayed the same. So we're going to start out in 1X. Let's show you drive. Hello, 1, 2, 1, 2. About 25 watts. And we're dead keying about a half a watt. Dead keying about a half a watt. So let's put that half a watt. Remember, this is 100 watt slug in peak, 100 on average, 5 watt slug in reverse. So let's guess here. Let's roll this dead key on up there. Bet you that's about a watt. Let's find out. Ha! 1 watt. All right, so 1 watt going in, gets you 20 coming out. Hello, 1, 2. So we're making about 80 bird. Let's go to 2X. Hello. Just a hair over 200 watts out in peak power. And we'll go all the way down. Hello. And this is on 14.9 volts, you guys. Now our input tune, let's go up here. Let's lock the camera so it doesn't float away on us. Amp off. Hello, 1, 1, 1, 1, 1, 1, 1, 1, 1. Amp on. Hello, 1, 1, 1, 1, 1, 1, 1, 1, 1. So input tune's good. Output tune's good. This amp is in a little bit rougher condition than the other one. The nuts are rusted. The cabinet's got extra screws in it. The paint is all faded away. This is after I cleaned it. This is all jet black around all the switches. So, say 100 bucks for this guy. And we'll make it go away. You can go find another home other than here. So, continuing on with the trilogy here. let's go to truck stop amp number 3. This thing's set. Oh. Let's make it so our tuners can't get moved around. Make it safe, publicly safe. The only problem with this is the way they switch the preamp on is they're passing ground through this inductor right here. Passing ground through this inductor, through the relay, and then back out through this inductor to ground. So when this relay switches, it breaks the ground connection here that drives this relay. The on-off switch on the front runs the positive connection around over here that actually charges up this side of the relay. So the inductor that come from here up to our input, if we look, our incoming RF comes around and it attaches to here, this connection. So we're actually passing ground potential and isolating through inductors. Totally doable. The RF just doesn't want to go that way. But is what it is. That inductor was burned up, and that was all that was really wrong with this one. I pulled the preamp transistor. It still got a gain of 307 on it. So there's really nothing more to be done. Real simple. Pride 100, a little beat down, but it's still a good little box. Okay, so we went ahead and we disconnected the, oh, this is dangerous. Separate those. Went ahead and we took the lid off the top so we can all see what's going on the inside. Now, I don't see any burnt 10 ohms. We're going to hook up our little alligator clips. Turn the amp on. Let's check our preamp. Preamp is working. Start out on low. We're going to start out with a 1 watt carrier. So let's go ahead. Back this on out a little bit. Power off. Hello, audio. We can talk through it. Amp on. Hello, audio, 1, 2. It's got problems. It's not making no power. So let's turn on our FLIR and let's figure out which one of these transistors is popped. Hello, 1, 2. Now there should be 2 hot spots in the middle of that screen. Hello, 1, 2. So it tells me that this 455 over here is popped. So without changing anything else in the amp, let's just take a hot minute. Now this thing come in here broken. So far the last 3 boxes that we've worked on have showed up that were sold as working have shown up in here broken. But this is a Motorola MRF 455, and I just happen to have more Motorola 455s laying here. So let's go ahead and let's whip this transistor out of here because it's obviously not turning on. And being that it is a push-pull configuration, it means we're not going to have any power. So let's get that pill changed out real quick and let's see if it hops right back up to life. Okay, so I put another Motorola in here, another 455. Let me grab a hold of this positive connection so it doesn't short. And no go. Then this transistor blew up. So it was just right on the ragged edge of dying too. So instead of sticking with that, I just went ahead and I put 2 2879 HGs in here. You know, $60 worth of parts versus a $60 single Motorola transistor. I'll live with it. I'll live with it. I want to show this working, and then I want to do the power wire upgrade to it, and then we'll call it finished. So right now, let's go over here once again, down to 1X. So let's show you radio drive. Let's see, amp is off. Hello, 1, 2, 1, 2. Up. We're up on 14.9 volts at the moment. Hello, audio. In the corner. So we'll go to 2X. Hello, in the corner again. Down to 5X. Hello. Hello. So we're making 275-ish watts through these shitty little connections. Here, let's run through the gambit while we're here. Let's just go through this one more time. Here's low, hello, 1 2 1 2. Here's medium, hello, 1 2 1 2. Here's high, hello, 1 2. 275-ish on high, about 250 on medium, and about 200 on low. Now remember, we're going through these little alligator clips, which are fairly warm at this point. Are we going to see a huge power increase? No, not at all. Remember, this is set up for 455s. Okay. And I'm not going to spend the time to retune this thing, but it'll run. I mean, it's making its 250 plus watts of power. Let's go ahead and let's change these power wires out and see what we get for results. So we went in and we moved the power wire over to the output transformer and just simply added a better grounding system on the inside of this. And if it puts out 1 more volt over 100 or 270 watts, we'll consider this a win. Same drive, same everything. Hello. Imagine that. Imagine that. Okay, truck stop amplifier number 3, done and done. Low, medium, and high preamp, everything's working on this. Got a little bit more money, a little bit more parts into this one, so we'll say $185. And plus the ride on all 3 of these. So let me put the tin on this, put the tin on the other 2, and we'll be back and we'll wrap this little thing up. Okay, done, done, and done. Pride 1, Pride 2, Palomar 250. You know what? 150, 100, and whatever. We'll say 150 for this. Done. Plus the ride on all of them. I'll mark the listing for this video accordingly. Pride 100A, number 1. Pride 100A, number 2. Palomar 250. I am done twiddly dinking around with these little tiny 2 pills. We are done. Done and done. The Mr. V project is, well, oh shit. Man, just when I thought I was out, eBay garbage sucks me back in. Mother fricker. Oh yeah, I haven't forgot about this one either. This is it, basically, for the tail end of it. We've got that. I'm not fixing this. I'm not fixing this. This don't work. The pills are blown in it. This is the one that uses these stud transistors. Not worth even fixing. So I will make sure I get that sent back to Mr. V. This one, I got something special planned for this one. So I guess the next video is going to be me undoing this Rudy Toot mess that's up inside of here. Fun times. Gentlemen, my name is BBI. And without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. You can find me on Facebook, Twitter, Snapchat, Instagram, and right here on YouTube Gargler. If you are not subscribed, you need to subscribe and smash that bell. Okay, I gotta go. I'll see you guys. Have a good night. Bye-bye.